Okay, just to clarify in the last video, I said that they're intersecting at a point, and visually that doesn't necessarily mean they're intersecting all at a point. It means they can be intersecting at a line where the planes are kind of going into each other. So I kind of gave that visual, and I'm also posting it on the portfolio so you can see it more clearly. Because in this situation, this is what the planes looks like when they intersected at -2, 1, and 3. Now for my next system, we have these. Here, I'm gonna hold them up. I messed up in the last video and I held it upside down, so I'm refilming now. So we have 2x plus y minus 3z equals -3, 3x plus 2y plus 4z equals 5, -6 minus 3y plus 9z equals 9. So those are our three equations that we have in this second system. And the first thing that I did was, for the first two equations, the 2x and 3x1, you can see right here, these two, I decided I wanted to get rid of x because in my head that was going to be the easiest variable to eliminate in this system. So when I did that, I multiplied the first equation by -3, the second one by 2, so we had a -6x and a +6x, so that we could eliminate the x values. And from there, I ended up solving to get y plus 17z equals 19. Now, the good thing that I had was that now I have a -6x at the bottom, and I just multiplied this 3x1 by 2, so that I got the 6x plus 4y plus 8z equals 10. There, I ended up getting y plus 17z equals 19. Now, the important thing to see here is that we have y plus 17z equals 19 twice for both of our solutions when we used elimination in the system. So what that means is that because they are the same solution, that the lines are actually going to be overlapping because they're the same. So that gives us the answer to number 2, which we're going to have infinitely many solutions or overlapping lines where we have an inconsistency. So what this is going to look like is it's going to look a lot like this. This is a really good example of what the visual would be. So you can see here, sorry, my phone's a little shaky. We have two planes, and I made it darker so that it looked like there were two planes. And then we have this one plane that's intersecting these two planes. Now these two are overlapping, and the intersection comes here between this plane and then these two planes. So that's kind of what the system would look like, the one that we just solved. That's an example of what overlapping or infinitely many solutions would look like in a 3x3 system. And I am going to move on to the next one, which is this system. Okay, so we have 2x plus 3y minus 8z equals 10, x minus 4y equals 1, and we have -2x minus 3y plus 8z equals 5. So the first thing that I noticed in this system was that these two seem to be the same, right? If we take away the 5 and the 10, we have 2x plus 3y minus 8z, but then we have a -2x minus 3y plus 8z. So if you were to look at this, you'd be like, okay, you could cancel out x, y, and z values, which would mean that we would have an inconsistency or overlapping planes. However, this is not the case because both of them are equal to different number values, which would mean that we have no solution in this case. So basically, no solution is going to be represented by a graph that looks a lot like this, where we have two parallel planes right here, and we have a plane intersecting the two parallel planes. Now, they aren't overlapping because the two solutions that we had are not equal to each other. They're no solution. So that means if we have no solutions, there's going to be no points of intersection, which would mean that we would have parallel lines. And that is why this system has two parallel planes with an intersecting plane, as the third solution that I ended up solving was not equal, the third solution was different, meaning that it would be intersecting the two planes. So I hope this video helped you visually understand what systems would look like graphed 3x3 systems would look like when graphed as planes. And in conclusion, we had our first system as review as -2, 1, and 3, 1 point. Our second one, we had overlapping planes because the solutions are both the same, and that would mean we had infinite solutions because they're on the same plane, they're going to have the same solutions. And then we have for the third one, we had no solution because the lines are parallel, meaning that they aren't intersecting and that there is no solution there. So I will be posting the pictures on Portfolio, so if you want to get some reference, go check it out, and I hope you enjoyed my task 2 part 3 Portfolio video.